Hello, hello YouTubers. In this theory of competition tutorial, I am explaining a magical formula for designing DFA with same substring. That means start with a substring AB and start with int with substring AB and consist substring AB. Okay, AB. Here I am taking as same substring to design start with, int with and consist with problem comparatively. One thing I prefer most that if you learn comparatively uh, among these three rules, three start with, int with, consist with problems, you will get a clear concept, I hope. So let's start without talking so much. uh, Here start with AB, hence number of steps will be length of accepting minimum state plus 2. Here accepting minimum string is AB, so plus 2 is 4. But for two others, uh, just add 1. AB add 1 3. And here consist with problem AB add 3. Okay, so comparatively you learn for start with you need to add 2, but for int with and consist with you need to just add 1. Okay, number of state. So here as you can see my number of state 4 A B C D, and they are int with number of state A B C, and here number of state A B C as I mentioned earlier. Okay, there are some tricks I written above is uh, is design, DFA design. I will implement it and explain it later. Okay, so here the summation sign simplifies the alphabet, hence the string consists with only AB. Our alphabet is A B. Okay, and here also our alphabet is AB, and here our alphabet is also AB. Okay, I am doing this comparatively because it will be more clear to you to learn comparatively. Okay, now here as you can see this is epsilon. Epsilon means to go to initial state. To go to initial state you need just epsilon, and then you have to write down in the first column A and AB continuously. If it is ABB, then the next row can be ABB. As we found our AB, that means this is our final state. Okay, and this is dead state. This is why we are taking extra state in start with problem, one dead state. Okay, and this there is also AB, so this is our final state. There is no need any dead state, and there is also AB. This is our final state. Okay, if you uh, anyway if you get this table, you will be simply able to design the transition diagram. The main is the transition table. Okay, uh, many people design the transition diagram first without any logical formula, but if you have any logical formula to have the transition table, then why should you first do transition diagram? Have you got this? If you uh, if you have any magical logical equation to fill the transition table, it will be a better way, isn't it? Okay, let's try. Take this epsilon and multiply this A. Epsilon A, and look there in the first column. Is there any epsilon A? As you can see, is there any epsilon A? No, there is no epsilon A. Then cut down one preceding letter. Then we remain A. Is there any A? Yes, A. That means A state for A will go to B, as A belongs to B. Okay, B. Again multiply epsilon to b. That means the row element to column element. Epsilon b. And find there is there any epsilon b? No, there is no epsilon b. Then cut one preceding letter. Is there any b? No. If there is no transition, I write it down there. The trick is, if there is no transition, go to dead state. Okay. This is the tricks. There are simple a few tricks to uh, remind it to memorize. If you memorize this simple trick, you will comfortably have the table effectively. Okay. Then proceeds. Okay. And for b, they are a to a. A, A. Is there any A? No. Cut one A. Is there any A? A? Yes, A. And this A belongs to B. We are traveling from B, but we found B. I write it down. If delta is same, make it dead. Okay. From B to B for A. From B for A. For as I written here, if delta is same, make it dead. After getting A from B to if you have another A, you need to go to dead state. Okay. Okay. Then again multiply this A to B. A to B. Is there any AB? Yes, C. Then go to C. Okay. And then come to the next row, AB. Then again multiply with AB with A. AB, A. Is there any ABA in the first row? No. Cut one preceding letter. Then we have remain BA. Is there any BA? No. Cut one. Oh, there is oh there is I have forgotten the tricks. If in final state, stay final state for any input. Is there because this is final state, we have to stay in the final state for any input. Okay. And for dead state also, we have to stay in the dead state for any input. This is true for dead state also. So this is the tricks, and this is how we got this transition table. And by following this transition table, we can simply design the transition diagram. Okay. This is our AB, and these are final state, and these are dead state. Okay. From A to B, for A we are going to B, but for B we are going to dead state, because if we found a uh, B at first, we will go to the dead state because we need AB. Okay. There we fill these two transition for A, and for B we have one transition only for B to C. But for what will happen if it have A in the B, here B to B for A go to dead state, it will go simply to dead state for A. Okay. And for any input, the C will be in the same state, and for any input the D will be the same state. Here is the solution for start with AB, and now get to the next into it. The same system, just only if no transition, go to initial state. For final state also, multiply epsilon to A. Epsilon A. Is there any epsilon A? No. Cut one letter. Okay. Is there any A? Okay. This is to B. Okay. Again multiply with epsilon to B. Same procedure. Epsilon to. Is there any epsilon B? No. Cut one letter. Is there any B? No. If not transition, go to initial state. That means A. Okay. And then again multiply it with A to A. Is there any A? No. Cut one letter. Is there any A? Yes. This is belongs to B. That means it will stay to B. Okay, and again for AB, A to B, is there an AB? Yes, in the this is in the 0. Okay, and for C, this means in the final state AB to A, AB, A. This means, is there any ABA? No, cut one preceding letter. Is there any BA? No, cut preceding letter. Is there any A? Yes, this is in the second row. That means we will go to the B state. Okay. Again, if we multiply it into AB to B, is there any ABB? No, cut one preceding letter. Is there any BB? Cut preceding letter. Is there any B? No. If no transition, go to initial state. Okay, this is the transition table, and let's fully filter it. These are final state. A, B. For A will go to B, but for B, A will stay to B. Okay, okay. And B, for B will go to C, but for A, stay will at A. And from C, for A, it will go back to B, and for A, it will go back to state A. Okay. This is how we filling our transition table and transition diagram. Okay, and now the last one is consist of AB problem. Here the same tricks, but some tricks, another tricks. No transition, go to initial state. In final state, stay final state. That means in final state, it will always stay in the final state. Okay. Now similarly, it will look like the intuit problem. So simply I can fill it as the intuit problem. Okay. Now for A will go to B. For B will go to C, and from A to B, for B will stay to A, and from B for A stay will at B, but for any input we will stay at C. Let's check this transition. Start with AB, C. If you find A, you will go to B. If you find B, go to C. And for any input, it will be at C. That means this is accepted. But if A, B, this will not accept it. Let's try. For A, it will go to B. For A, it will go to dead state. Okay. So this is not accepted. And again, let's try for intuit. Suppose A, B, B, A, B. Let's check it. For A, it will go to B. For B, go to C. And for B, from C to this means okay. For B, from C to it will go back to A, and again it will go for A to B, for B to C. So this is accepted. Okay. But if we have any A, B, it will for A it will go to B, and again if it will stay into that. No, this is accepted, because in the last there is, if we okay, if we add another B, this will not be accepted. Let's check it. For A it will go to B, for A it will stay into B, and for B it will go to C, for B it will go back to A. So this is not our final state, so this is not accepted. And for consist of, suppose A, B, this is accept, this should accept because there is AB. For A it will go to B, for A it will stay to B, and for B it will go to C. So this is accepted. But if you have, if we have only A, it will go to B. It will, for another A it will be at A. Okay. So this is not accepted. This is how you can fulfill. You can try to solve this three types problem at once, but only memorizing these tricks. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.